So good evening all. This is Mallikarjun, Assistant Professor in Malaria Engineering College. So today I am going to explain about the topic of three-phase inverter. In three-phase inverters, we have again two types. One is 180 degrees conduction mode. Second one is 120 degrees conduction. First of all, before going to the topic, three-phase inverters, first of all, what is the definition of inverters? So usually we knew about that inverter. We are observing in our day-to-day lives, in our home, and like domestic application means homes and commercial applications, and wherever we go for industrial side, like aerospace, wherever you go, anywhere, inverter is mandatory now for constant supply, to get the constant. So first of all, what is the definition of inverter? Inverter means it is a static device. It converts DC power to AC power at a variable voltage and variable frequency. Is nothing but the output side is variable. We need AC supply, that is AC supply. If you go for single phase inverter, that is single phase AC supply. If you go three phase AC supply. So depends upon the load we use, and depends upon the loads, we can use either single phase or three phase. And this is the definition of the inverter. But now coming to the types of the inverters. Inverters are basically two types of inverters: single phase and three phase. Single phase inverters again divided into two types. One is single phase half bridge inverter. Second one is single phase full bridge inverter. Coming to the three phase inverter. Three phase inverter means input is single battery, single supply, only battery that we can use. At the output side, that is the AC side, load side, is three phases. We need three phases. Okay. So that is three phase. Three phase inverters are again two types: 180 degrees conduction and 120 degree conduction. So now we are going to see the topic that is 180 degrees conduction mode. Here I told you already just now, we have discussed about this, what is the definition of the inverter and how many types of the inverters. Okay. And next, applications. Applications, I told you just now. Applications are first and major application is, that is uninterruptible power, means UPS. At UPS side, because a load is always there. For example, if you see that like UP fans, domestic side fans or variable speed, you can use the induction motor there, and some example vehicles there, that is another load. If you go for the refrigeration and washing machines and systems, wherever if you go, loads are changing. The speed of the load is changing. Means variable variable voltage and variable frequency we should be applying. AC supply with variable voltage and variable frequency, because load is not a constant. It is variable. It is varying always. It has been varying always. Next, industrial and commercial applications. For example, AC adjustable speed drives, that is ASJ, and induction heating. Coming to inverter is next. Inverter is used for the controlling the AC motor drives input. So we know already drive is nothing but it is one of the main important terms in power electronics, like drives, motors or generators, AC or DC. Drive is nothing but it is a system required to control the motion. That is nothing but a drive. Drives are again two types: mechanical and electrical. And electricals are again AC and they are different. That is no need now. Just we are focusing on this 180 degrees conduction mode. This is 180 degrees. Next is domestic applications like refrigerators, air conditioners, okay, and etc. Fans and washing machines, like different roads, blowers. All are the variable domestic loads. These are single phase but domestic. It's a low power side. And inverter is very essential for controlling speed of the compressor. And next, regulating the required. We need proper active power only. We don't need unwanted or reactive. We need only active power. That is why we should be getting a proper. That is why we can use a regulator also. We need pure is separate output load side. Inverter is primarily used in the solar energy systems and wind turbine systems. And then what is the principle of the three-phase inverter? Principle of operation of three-phase inverter? Very simple operation actually. A three-phase AC power can generate by using the three independent DC to AC connectors. Like input side is only single phase, single DC supply or battery, but output side is three single phases and also one neutral wire. Means three phase 4 wire star or star connected system. That we are going to see in the circuit diagram, and we just now discussed about 180 degrees and 100. So 180 degrees conduction mode means in three phase inverter, we are using six thyristors and 6 diodes. Okay. In 180 degrees conduction mode, each thyristor conducting 180 degrees of operation. Next, in 120 degrees conduction mode, each thyristor conducting 120 degrees. But circuit diagram is same for both. For both cases, the circuit diagram is same. See here, three phase 4 wire star connected load, and its load side, the load is each phase independently connected to switch. So in the upper switches, and upper switches means three upper switches, and lower switches are three phase. Upper switches are S1, S3, S5. Lower switches are S4, S6, and S2. And one neutral is also connected. These signals are displayed by 60 degrees each. So coming to the operation circuit diagram, just now I told you that is 6 thyristors are we are using in three phase. Means Okay, three phases. This is the first phase T1 and T4 are first wings. Second phase B, first phase A, second phase B, third phase C. A, B, C. Three phases, and each phase connecting two resistors T1 and T4. First phase A phase, T3 and T6 at B phase, and T5 and T2 C phase. And also we are connecting one capacitor, that is parallel capacitor. It is very essential to maintain the constant supply voltage, and also it gives the feedback for if whenever the problem is occurring or whenever the disturbance is occurring at the load side, it gives the it takes from that and it gives to supply. Means it is a feedback path, like it is operating as a feedback path feedback element, and also it maintains the constant supply. And here we are using also six diodes D1, D3, D5, D4, D6, D2 are connecting anti-parallel to each and every diode. Means these are also for feedback or feedback path only. Feedback whenever the thyristor T1 is not whenever thyristors are not conducting, meanwhile we can use these diodes up to 1 to 6 diodes. Phase A, phase B, phase C. Okay, and also we have a neutral wire that is N, and we have phase voltage VAN across the phase A and phase B, and VAN and VBN and VCN. And next VAC and VAB, VC and VCA are the line voltages. So these are the modes of operation. When equivalent circuit diagram of modes of operation. This is a table. Okay. For example, each thyristor conducting, I just told you that 180 degrees operation. That is why each thyristor conducting 180 degrees only. So that is why here. See, for example, in mode 1 from 0 to 60 degrees, thyristors T1 and T6 and T5 are conducting. Means T1 is positive group, T5 is also positive group. But T6 or S or T, whatever it may be, you can consider here. They consider here S. We just consider group, that is T. T or S, that is okay, no issue. The T1, T6, S1, S6, S5 are the thyristors conducting duration of 60 to 0 to 60 degrees. And these are the phase voltages. Phase voltages VAN, VBN, VCN, and the line voltages VAB, VBC, and VC. VAB is nothing but VAO minus VBC. VBC means nothing but VBO minus VCO. VCA is equal to VCO minus AO. So this is the first mode from 0 to 60 degrees. Here S1, S5 are the positive group or upper side of the thyristors, and S6 is the negative group or lower side of the circuit diagram. Here means S1 means phase A, S5 means phase. That is why after calculating, after drawing the topic. So this is a mode 1 operation. Mode 1 operation S1 and S5 are positive group, S6 is the negative group. Means you can draw equivalent diagram at in mode 1 operation. Means A, B, AC, next B, and this is the star connection. VAN and VBN and VCN, and these are the resistors or these are resistors, and voltage divided into two parts, V by 2 and V by 2. So after modifying this like this, we will get VA and AC sub, this is AC and A and the AC is the V by 3 voltage we got, and B phase, this is the phase voltage across the resistance, and this is also phase voltage across the resistance. AC is the AC of the positive group, nothing but voltage also we got V by 3, positive supply, positive voltage, output voltage, phase voltage, and VBN is nothing but we got here minus 2V by, that is the negative value. This is a neutral one, neutral terminal. This happens in the operation of mode 1. See, in mode 1 operation means thyristor 1, thyristor 5 and thyristor 6 off. Remaining thyristors are all open circuit or reverse bias. T1, T6, T5 are only the conducting. Means we are giving supply, positive supply to T1 and positive supply to like T6, and this is the phase A supply, next phase B supply and phase T5 to T5. Okay, A, B. Okay, yes. Here T1 is A, phase A and phase positive supply. But the negative supply we are giving to the T6, that is T6, B phase. Okay. A and C are the positive, B is the negative. That is in the case of mode 1 or first case. Second case means duration from 60 degrees to 120 degrees. Here the thyristors are T1, C1 or S1, S1, S6 and S2. S1 is only the positive group or upper, is nothing but A phase. S6, S2 are the negative group, means B and C phases. The phase voltage after finding the equivalent impedance and also they substitute the formula, they will get the voltage, phase voltage, that is phase A. VAN voltage is equal to, whereas 2V by 3 and VBN and VCN are the negative voltage, minus V by 3 and minus VBN. These are the phase voltages across VAN, VBN and VCN in second mode. See, in second mode, thyristor T1 is conducting. Okay, next thyristor T6 is conducting from negative side, and so thyristor T6 and T2 conducting. Next T1 in mode 2. In mode 3, similarly from 120 degrees to 180 degrees operation here, S1 and S3, S2. Means S1, S3 are the positive group thyristor, means A and B. S2 is the negative group, that is C. So means S1 means phase A, S3 means phase B. Both are same values and positive values because positive group. And the next S2 is the negative group thyristor, that means lower part, minus 2V and V by 3. We got minus 2V by 3. If you wanna clear explanation, then you can see this circuit diagram. S1, okay, S6 and S2. The mode of operation and the third mode operation here is A and B are positive, C is the negative. So after equivalent circuit diagram, after modification of the circuit diagram, equivalent circuit diagram, we will get AB is the V by 3 and C is the minus 2V by 3. This is negative. This is the mode 3 operation. We just happened. Next, coming to the fourth mode, from 180 degrees to 240 degrees. Here, thyristors are 3 thyristors only. Okay, and those are S3, S4 and S3 and S2. S4 is the negative group thyristor, S3 is the positive group, S2 also positive. Negative. S2 is negative. Means the voltage, phase voltages after calculation, after substitution, after finding the equivalent circuit diagram, after drawing the equivalent circuit diagram and substituting the value, impedance value, and by the in the Ohm's law formula, like our current is input, we got phase voltage here like this. VAN is equal to minus V by 3, and VCN also minus V by 3. Means both are negative group resistors, and VBN is the positive group, OV by 3. The operation, equivalent circuit diagram of the fourth mode or mode 4, A, B and C. Yes. Means AC is the positive, V by 3. ACN and AN and VAN and VCN are the positive group. VBN is the negative group. Next, similarly, 240 to 300, S4, S3, S5 are the thyristors conducting. S4 is nothing but negative, S3 is positive, S5 also positive. Means A, B, C, B and C are the positive voltages, positive phase voltages, VBN and VCN, and VAN is a negative phase, lower part while conducting, is conducting now. So means nothing but minus 2V by. Next, from 300 to 360 degrees, S4, S6, S5 are the conducting. The phase voltage is minus V by 3, minus V by 3 and plus 2V by 3. These are the modes of operation in 180 degrees conduction mode from 0 to 300, 0 to 360 degrees. And these are the waveforms, phase voltage and line voltage waveforms here. And these the phase VAN and VBN and VC. I didn't draw any value here actually because of the lack of space or namely that is, and VAN and VBN VCN phase voltage. Coming to here, these are the phase A. In phase A, A phase T1 and T4, B phase T3 and T6, C phase T5 and T4. Means T1, T6 and T2, T4, T5 and like that T6. These are the waveforms of 180 degree conduction. So this is about three-phase inverter with 180 degrees conduction mode. And also okay, thank you.